Okay, in this section, first of all, just basically having a refresher on some of your properties of logarithms, and then we're going to get into finding the derivatives of your natural logs. Of course, you're accustomed to using these properties with your natural logs, which is the properties how I have them listed here. You've also used them with like your common log or just other logs, whether it's be base 5 or base 6, where you have log. Properties work in both situations. Anytime that you have the natural log of +1, you have a +1 in your argument, then that's always going to be equal to 0. If you have multiplication within your argument, then you are allowed to separate this into two separate log terms. When you do the natural log of the first factor and then do natural log of the second factor, but then you do have to add between those two terms. Okay, next we have the natural log of a to some power. So when part of your argument is raised to a power, your property tells you that you can multiply your power times the natural log. So basically it looks like you take it and you move it to the front, but what you're doing is that power times this natural log. And then the fourth property is when you have division here within your natural log, then you are allowed to, again, turn this into two separate log terms, but you would need to subtract. So it would have to be natural log of the top minus natural log of the bottom, okay? All right, so now what we're going to do is take these properties and apply this to some of the problems. All right, so you're told to use properties of logarithms to expand the log expression, okay? So when you're looking at your argument, you need to look to see, do you have multiplication, do you have division, do you have exponents, okay? In this case, I actually have all three, but what you would take care of first is the fact that you have the fraction. So the property tells us that we can do natural log of the numerator minus natural log of the denominator, okay? Now I have some more of those properties that can be applied to this first term, because here I have multiplication, because I have 3 times the x squared. So my property tells me that I can separate those factors into two separate terms, but then I have to combine that with addition, okay? Now bring down your minus natural log of y, don't lose that. And I've got one more step that I can go here with my middle term, and that's because I have the power on it. So our property tells us that we need to do the power times the natural log. Like I said, basically the appearance looks like that you just take your exponent and bring it to the front. So this would be what's called the expanded form. Next, what you would need to do on the second one before you actually start using your properties is to rewrite the square root of x plus 5 as x plus 5 to the 1/2 power, okay? And that way you can use the property that's referred to as the power rule, the one that I used just a few minutes ago. Okay, so I've got multiplication because I have the x times the x plus 5 here. So I'm going to separate those factors, but you would need to add those two terms together. So you're separating multiplication, you have to combine the two terms with addition. Okay, next I would need to use my power rule on this second one here, because this argument is to the 1/2 power. Okay, and that's actually as far as you can go here. If you have addition in your argument, then there's not anything you can do. It's when you have multiplication that you separate it with addition. So it's not that you start with addition and separate with addition, okay? Now, you can also take and reverse this. It's referred to, most textbooks refer to it as condensing sometimes. So basically it's working backward from what you just saw. Now it says to write it as a single quantity, And that means when you're done, then you're just going to want to have just natural log and then have the argument. So ln, or your natural log, would actually only be in your answer one time. Okay, what you need to deal with first here is the fact that you have 3 times your natural log, which if you're using your properties in reverse order, that means that 3 originally would have been an exponent. So now I'm going to have the natural log of x minus 1 to the 3rd power plus natural log of y. Now, since these two are separated with addition, like I said, same property as a while ago, just in reverse order. If they're separated with addition, that means then what you're to do is to bring it back together, but to multiply. Okay, so when they're separated by addition, you put them back together by multiplying. Now you can put the times y at the end, or you could put it in front and it would still mean the same thing. But the single quantity meaning, you notice when I'm finished here, I only have ln written one time in my answer. Okay, now on this one, there's actually a couple of different ways you could do this, but what I would suggest that you do first is deal with what you have inside the bracket here, or it could be a set of parentheses. So since these two are separated by subtraction, that means that when I put it back together, that's going to give me a fraction. Okay, so just like a while ago when I had a fraction, I separated with subtraction. So now that I've got them separated with subtraction, I put them back together into one term by making a fraction. Now, 1/2, so the 1/2 has got to go back here to be a power. Now, it's got to be on that whole argument, so that whole fraction is being raised to the 1/2 power, which would mean that that whole fraction is a square root if you take it back to the radical form, okay? All right, next, just a little bit of information about the number e. All right, now e is a number which is approximately 2.72. It's just an irrational number. Therefore, you know, these decimal places just, you know, keep going. So basically, you just see it approximated as 2.72. Now, e is the base of your natural log. So, you know, if you're used to seeing the little bitty subscripts, you know, a lot of the times when you're writing logs, but when you're writing natural logs, you know, then you don't see a little subscript, okay? So like for instance, let me pull this back up here. See, I don't have anything here, 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 or here. But every time that you have an ln, your subscript is always understood to be an e for every single one of those situations, okay? So that's what, of course, this is expressing to you here, that this subscript is an understood e. Now, a couple of properties. Anytime that you have natural log of e, then that's just going to be equal to 1. Anytime that you have natural log of e to some power, then it's just going to be equal to that power. And actually, if you remember this one right here, if you remember this property is actually also this. Okay, so I've just told you that this is understood to be an e. So anytime that these two things are exactly the same, then your answer is going to be whatever that exponent is, okay? And that's actually the situation that I have here, because I've got an understood e here. So since these are both e's, this is going to be equal to whatever my exponent is, which my exponent happens to be an understood 1.